Good morning, and welcome to our HCL Informix technical user session. I'm Mark Tritaris from Actian, and it's great to see so many Informix practitioners joining us from across APAC. The goal today is simple: give you practical takeaways you can use immediately, things you can bring back to your team and apply in real environments. Before we begin, quick housekeeping. Please drop questions in the chat as we go. We'll capture them and either address them at natural pauses or in the Q&A so we can keep things moving. Now, just to set expectations, here's how we run today. We'll start with what's new in Informix 15.0.1 with JC Liew, our Chief Informix Architect. JC really needs no introduction. He's globally well known in the Informix community and one of the most trusted Informix voices. Next, we'll move into modernizing Informix with an expert practitioner's perspective from Liew Kim Non, Managing Partner at DBAs Technologies Consulting. Liew is actively involved in promoting Informix across Malaysia and Southeast Asia, organizing Informix technical events, advocating for the IIUG community, and he's recognized as an Informix champion for his contributions. So today you'll hear what teams are actually doing in the field, what works, and practical patterns you can borrow. After that, we'll cover upgrade guidance to Informix 15 with Nag Balakrish, Channel Sales Engineer at Actian. Nag is a seasoned technologist with over a decade of experience across databases, big data, and data science. So this will be a very practical, implementation-minded session focused on reducing risk and making upgrades smoother. And finally, we'll wrap with secret support tools, practical techniques that can help speed up diagnosis and resolution when issues pop up in real environments. All right, thanks everybody. So let's kick off with the part that everybody's here for. What's new? JC, please take it away with Informix 15.0.1.
All right, thanks, Mark. It's good to be here. Thanks for joining the webinar. I've got about half an hour to tell you a lot of stuff, so I'm going to dive right in here. In version 15.0.1, we have faster I/O on Linux for certain devices that I'll tell you about in a minute. And across the board on all platforms, we've improved the performance of the checkpoint flush times, and I'll tell you about that. If you use RChecker to do table level restores, those can be done in parallel in 15.0.1, and that will be significantly faster than what you're used to. We've added some features to the create database statement to allow you to indicate what the default locale is for the database at that time and the isolation level and other things I'll tell you about there. And every time we release a new version of HQ, there are enhancements or new features in that, and I'll tell you what the latest one has. And we've actually been working on 4GL. 4GL is something that we've been sort of maintaining for a long time and not putting new features into, but we're starting to put some new features in that you might be interested in. So I'm going to tell you about that too. Let's go to the next slide. So the first thing I'm going to talk about is why I/O is going to be a little faster on Linux for a lot of you, and how we managed to do that. Next slide, please. So first, we have to give a little background here. When the Informix server writes to a chunk, it makes this write call. That write call cannot return until the data is actually on persistent storage. We have to know that the data is on disk when the write call returns. We can't just write to some kind of file system cache or device cache or something like that. That's not going to be enough for our recovery code and other SLAs. So we open each chunk when we boot the server, we open each chunk with a sync flag. And if we end up going through the kernel cache or a device cache, we might write a buffer out to that cache and it might be copied into the cache, but that cache is going to have to be flushed because of the sync flag to disk before the write call returns. And as you can tell, in that kind of scenario, the file system caches and device caches are sort of useless middlemen that are in the way of the top I/O performance. And so that's where direct I/O comes into play. We can also open a chunk file with another special flag that indicates that we're going to write directly to the disk. We're going to bypass all caches and mechanisms associated with the caches and write straight to the sectors on disk. And that's direct I/O. But there's a catch with direct I/O, and that is that when you write from memory to the disk, the memory has to be aligned in a way that's compatible with the disk. And that was the tricky part to getting this to work in earlier versions, but we've gone through the code in 15.0.1 and ensured that things are aligned properly, and we can actually do this direct I/O to disk now. And if we go to the next slide, I'll show you a little picture of this. So here's a picture of a 4K buffer in shared memory that is aligned on a 1 KB boundary. And as long as the disk that we're writing to has a block size of 1K or 512 bytes, that is compatible with the disk. That alignment in memory is compatible with the disk. And so we can do direct I/O to this disk, and we do direct I/O in version 12 and earlier versions of 14 and all that using this kind of block size on the disk. And we'll go to the next slide now, and we'll take this same 4K buffer in memory that's aligned on a 1K boundary. If we attempt to write that to a disk write it directly to a disk that has a 4K block size, that will not work. We will get an error because those two alignments are not considered compatible. So let's go to the next slide and we'll see what we did in 15.0.1. That previous slide was showing 15.0.0 and earlier versions of 14. This is 15.0.1 now. As I said, we've gone through our code, the server and utilities, to make sure that any I/O we're doing is aligned on 4K. You can kind of see at the top that this 4K buffer is now aligned on a 4K boundary. Direct I/O to a disk with 4K sector sizes will work now. And this is significantly faster than, I should say, we can write, even if we aren't aligned perfectly, we can write to this disk. We could use these 4K devices before, but we had to downshift to our asynchronous I/O mechanism and not use direct I/O for them. And that results in multiple copies on the way down and just a mess. The I/O performance is terrible. So people on Linux for years with these 4K devices, which are becoming more and more common, would tell us, we can't use them with Informix. They're useless to us. So we need you to figure this out. And we did finally do that in this version 15.0.1, thankfully. Now your DB space page size does matter here. If you're using 4K devices on Linux and your page size going to that device is 2K, direct I/O isn't going to work for you. It's not going to do you any good. So your page size in this case needs to be 4K or 8K or some multiple of 4K in order for us to use direct I/O with this device. But not only are we bypassing the caches and all the mechanisms associated with that, but we're writing in pretty large block sizes and in ways that are very compatible with the formatting of the disk. So the I/O performance is really good. And where you'll notice this first is with your checkpoint flush times. Let's say that we have non-blocking checkpoints. So the actual blocking portion of a checkpoint is very short. But after that phase, then we have this flush phase where we're synchronizing the pages in shared memory with disk. And that can take, depending upon the size of the system, that can take a minute or more. If your flush phase for checkpoints is taking a minute now, and you then move to direct I/O on a 4K device on Linux, you'll see that flush phase cut in half at least. So we saw that internally with benchmarks, so we're confident in that number. So let's go to the next slide, please. So a totally separate way in which we've improved the performance of that checkpoint flushing phase is with this other feature called parallel checkpoints. If we go to the next slide, I'll show you what I mean. This is sort of depicting, okay, so this feature is most helpful for people who are using a variety of page sizes. If you have if you have the base page size in every DB space, you're still going to benefit a little bit from this feature, but not nearly as much as if you have a variety of page sizes. So let's say that you have page size A, B, and C. That means you're going to have 3 separate buffer pools in shared memory, one for each page size. You're going to have some clean buffers in there, buffers that haven't been modified, in other words, and you're going to have some dirty buffers, meaning buffers you've modified at checkpoint time that we now need to synchronize with the disk before the checkpoint can be considered complete. So we'll show you that algorithm, the old algorithm, on the next slide. This is in version 14.10. By the way, that direct I/O feature is actually been backported into the latest 14.10. 14.10 XE13 has that support for 4K devices on Linux, along with version 15.0.1. This feature is only in 15.0.1. So let's look at the 14.10 algorithm here. Step 1, we go to buffer pool A. We gather all the dirty pages and sort them according to physical address. And then we pass them off to the cleaner threads. Let's say you have 6 cleaner threads configured, but there are only 2 chunks with this that use this particular page size. During this part of the flush, only 2 of your cleaner threads will be engaged. The others will be sitting idle. After that flush is done, then we move to the next buffer pool. In step 2, we gather the dirty pages, we sort them, we send them to the cleaner threads. And however many chunks are involved there, that's the number of cleaner threads that will be flushing at that time. And then we do the same thing for the next buffer pool, etc. So in the last phase of each buffer pool flush, the cleaner threads may be flushing things in parallel, 1 thread per chunk, but that's the extent of the parallelism in the old algorithm. Now let's go to the next slide and we'll see the new algorithm. So this is all done in 1 step basically now. All 3, we have multiple threads searching all the buffer pools for dirty pages, gathering them, sorting them, and passing them off to the cleaner threads who are now all engaged at the same time. There are no idle cleaner threads unless you've got a tiny number of chunks and more cleaner threads configured than your number of chunks. They're all going to be engaged during this flush. So the combination of 4K device support on Linux and this new checkpoint flush algorithm means that your checkpoint flush phase is going to go a lot faster, at least on Linux. The 4K device feature wasn't needed on AIX, for instance, because that platform is already covered. This really was a problem mainly on Linux, that 4K device problem. Okay, let's move to the next slide. So if you've ever used the ArcChecker utility to do what's called a table level restore, you can use this utility to pull a table off of an archive and either overwrite an existing table or create a new table and then cut over to the new table if you want to use that one in your application instead of the original one. A lot of people do use this feature to restore tables using ArcChecker because otherwise you have to spend potentially many hours restoring the whole system with OnBar or OnTape. But in 14.10, for example, you might have a table that's fragmented across 10 DB spaces. And if you want to do a table level restore of that guy, we're going to we're going to restore one fragment at a time. We're going to read one fragment from the archive and restore it and read the next one. If you go to the next slide, we'll see that algorithm. So here's kind of a depiction of that. We're reading in one stream from the archive, and our checker is restoring one table fragment out of many at a time, and we just do this in series. That's 15.00, that's 14.10, 12.10, etc. Now we move to the next slide, and this shows the 15.01 algorithm. And I realized that this picture doesn't actually quite do the new feature justice because it looks like we're reading in one stream from the archive. But if that archive is an on-bar archive, then each DB space is backed up as a separate object in the storage manager. So our checker will actually be reading from the archive from multiple objects in parallel if you've got a table that's fragmented across multiple DB spaces, and it will be restoring all the table fragments simultaneously. So that can significantly reduce the time it takes to do a table level restore. Now, I should say this is the physical restore of the table. If you need to read log files to do a logical restore with ArcChecker as well, we can only do that in one stream, that second phase in one stream, but the physical restore will be a lot faster. Next slide, please. Oh, here's another feature in ArcChecker that's sort of related. We've had, I shouldn't say new fragmentation schemes. They were new in 2013 with version 12.10 XC1. New schemes like range interval fragmentation. At that time, we didn't update ArcChecker to understand those fragmentation schemes. For those of you who haven't used ArcChecker to do a table level restore, you give ArcChecker a create table statement with all the fragment expressions and all that, and it will search the archive for that table and then create a new table with either the same fragmentation scheme, or you can give it another create table statement for the target table. And obviously it understood round robin fragmentation and expression-based fragmentation, but it did not, until 15.01, did not understand range interval fragmentation, which is becoming a very common scheme for people. So that was a big limitation there. And now it can handle that, and we're hoping that that will make it all the more useful for you. Next slide, please. So we've improved the syntax of the create database statement a little bit and added some features. We'll go to the next slide and I'll show you what those are. The most interesting ones are the default isolation level and the locale. It used to be that in order to set a locale for a database, you had to set this DB locale environment variable and then create the database, but sometimes it was unclear what the environment variable was set to, and there'd be mistakes. This allows you to explicitly say, when I create this database, I want the locale to be whatever. So that's convenient. And by default, an isolation, we're always going to start with committed read isolation level for databases that use logging, but now you can specify a different default isolation level, such as repeatable read or whatever. And your applications don't have to be constantly toggling back and forth between their isolation levels, depending upon what database they're using. They can just use the database and they'll get that default isolation level unless they want a different one. So those are the more substantive features that we've added. Something a little more cosmetic is you can now explicitly specify all log modes. It used to be that when you just said create database JC, that was assumed to be a no log database. Or if you wanted logging, you say create database JC with log, and we would presume you meant buffered logging. But if you wanted, excuse me, in that case, we would presume you meant unbuffered logging, but if you wanted buffered logging, you'd have to explicitly say with buffered log. Now you can say with no log, with buffered log, with log mode ANSI, or with unbuffered log. Hopefully that'll be helpful. Next slide, please. Okay, so we developed the server and HQ in a decoupled fashion. So we might release 1 or 2 versions of the server every year, but 3 or 4 versions of HQ, or or one. The schedules are decoupled. But every time HQ comes out with a new version, there are enhancements and new features that are usually pretty nice. So I think that the latest version of HQ is 3.20, and on the next slide I'll show you a list of things that are in there. These are all nice features, but the two that I want to highlight are the Swagger API and the utility support. If you ever used the OpenAdmin tool, which was sort of the precursor to Informix HQ back in the day, you were able to customize it in ways that you haven't been able to customize HQ. You could actually write your own UI on top of OAT, and it was quite nice that way. People had more access into the inner workings of OAT than they've had with HQ, and there have been a lot of feature requests there. So now in this latest version of HQ, you can use the Swagger API to make REST calls to HQ, and you can actually build your own UI on top of that. So that should be really nice, I think. And people have also requested that you be able to run DB import and DB export and DB schema directly within HQ, and now you can do that. So if you're not using HQ, I think you'll really like checking it out. Next slide, please. Informix 4GL has been a workhorse for Informix for so long. And we haven't really been updating it in terms of new features for a long time. We've just been sort of maintaining it. 4Js is a really great partner that took the product and ran with it, and now they have their own GUI, and it's a great product. And so when people want more from their 4GL, we often send them to 4Js for good reason. But we've had customers ask for some features in native 4GL recently, and so we've started doing that. Next slide, please. So the game-changing moment was version 15 of the engine. In that version, we went to a much larger row ID by default, and so all of our client code and ODBC and JDBC code had to be, we needed to do a fair amount of work on them to get them to understand this new row ID. So, and the same was true for 4GL. Last spring, I think it was, we released 751 FC4 of 4GL, and that understood the version 15 structures and the new row ID and was fully compatible with version 15. And you could create or access large tables with that version of 4GL, and that was great. But while we were in there, we thought, why don't we do a couple more things? And because of requests from customers, we decided to add some web services support to 4GL. And we don't have anything released yet, but we're still in the process of doing that. One of the things you really need to make 4GL able to both consume and publish web services is native JSON support. And we don't have that yet, but a step on the way is giving it native LVARCHAR support, which it didn't have until this latest version. So 751 FC5 of 4GL, which has been released, has native LVARCHAR support. And we're going in, probably pretty soon, we're going into a beta phase where we're going to be testing, with the help of some customers, web services consumption by 4GL. And once that via REST. And once that is working, once we've finished with that beta, we're going to start working on the publishing side. And eventually we'll be hopefully putting in native JSON support. We couldn't do that without native LVARCHAR support though, so that's the step we've taken with the latest release. And the other nice thing about the latest release is that it's available on PPCLE. Next slide, please. Yeah, so this is talking about what's coming. Hopefully this year is the REST extensions that are going to allow for web services. As I said, 4Js already does web services. They already do things really well, but there are some people who really want to stick with our products, and they wanted this feature, so we're happy to give it to them, and we're in the process of doing that. Next slide, please. So this slide's a little busy, but the main takeaway here is that if you're using a version 15 backend, you really need to recompile your 4GL applications with either FC4 or FC5. Our clients are forward and backward compatible, so you can use an older client with version 15, but it won't be able to access large tables. And there are some features of version 15 that it won't understand. It won't wig out, but it will not be allowed to access large tables, for example. So you're going to want to recompile your 4GL applications with either FC4 or FC5 for them to work hand in glove with either version 15.0.0 or the new 15.0.1. And you're probably going to need to do that recompilation on Red Hat 8 or above. Earlier versions of Red Hat, I don't think will work very well with FC4 and FC5. That's the main takeaway here. So I'd like to turn over the presentation now to Kim Non, who's going to talk about how the marriage of DBSolve and Informix is a match made in heaven.
Thank you, JC. Good morning, good afternoon, good evening, and good day, all my Informix friends all over the world. Thank you for joining this event, and I will do my best and share you why organizations should consider modernize your Informix system with HCL Informix. Well, next slide. Well, a quick introduction about myself. I'm Liew. Thanks for JC brought up. So Liew is my surname or my last name. Kim Non is actually my given name. So it's okay that you can call me Liew or you can call me Kim Non. I'm accept orders. Okay. Well, I'm the managing partners of DBSolve Technology Consulting. In year 2004, we are incorporated in Malaysia, and basically we are focusing in providing end-to-end Informix technology support and also consulting for Informix users in Malaysia and over the region as well. Next, please. Well, for information, we are not the only Informix partner in the world. You can connect with many others HCL Informix partner registers in Actian portal. Yes, I know most of them. We are all play a very important part as a member in the International Informix User Group. So most of them are very, very reputable, and they are very good Informix people who can help you in terms of upgrading your system or supporting your system. So next, please. And next. Oh, okay. I spent somehow I just feel like I'm the dinosaurs to Informix world. I recall my first database experience was Informix version 3.30 in year 1987. Well, looking back, I almost spending 2/3 of my life working for Informix. I mean, Informix front-end tools like 4GL, SQL, the back-end tools like Standard Engine, Dubo Engine, Online Engine. Actually, I'm not too sure how many of you know this Informix products, but I'm quite sure most of you knowing those IDS product, those are Informix Dynamic Server like version 7, version 9, version 10, and version 11, and version 12. And most of these versions are end of support, probably end of marketing, definitely end of marketing. But of course, I believe that you all know that we have current this what supported version, and is still in the market for marketing. There are version 14.10 and version 15. So today, I believe that JC already briefed you many new features which is incorporated into the version 15. So later probably you can get more information from JC about those new features. I mean, also to tell you the truth, after so many years of working in Informix, I still don't feel that I would like to retire from the Informix family yet. Now I'm still pretty busy with the Informix project, especially for version 15. So I hope that you can give me a ping so we can talk more about Informix version 15 project. Next. About my day-to-day Informix work. I'm still actively providing Informix technical assistance and support to our clients who deploy their mission-critical OLTP application or maybe management analytical reporting application which powered by Informix. So I do helping Informix customer manage and secure their hundreds of gigabytes or even terabytes of Informix data environment. Part of my job scope, I love to provide advice, give technology updates, and support Informix client in migrating and upgrade their Informix system to the latest version. Especially now we are talking about the Informix version 15. Next, please. Well, I really like to travel and voluntarily to spend most of my available time meeting, sharing Informix knowledge, and helping Informix users from or outside Malaysia. So if you need my presence in your local user group events, please give me a ping or an invite. I will be there for you, and you should be able to get my contact from this event organizer. So I can share, I can be there with you, with your local user group, and talk more about the Informix experience. Next, please. Well, many people know me as the happy fisherman Liew. So off the record, I wish you could invite me for a local fishing trip too. Cause my job also a fisherman. I like to fish. I know I'm the lucky guy working in Informix, and I always share a slogan with my friend that Informix is for people who know how to fish. Because once you properly configure your Informix system, you know the Informix will just work and is stable, reliable, easy to manage, and you can plan more time for your fishing trip. I mean, my fishing trip, or maybe some of you maybe can plan more time for your golf or many others event. Thanks. Next, please. From years of Informix experience and common users feedback, well, I really would like to skip this slide because many years of Informix working experience, mostly positive feedbacks come from Informix users. I mean, you almost like having like near zero downtime, and the capacity you can scale horizontally or vertically. And the management of the Informix system is also pretty easy and low cost because you still use the same on-stack command. So on tape, on bar, Well, from version to version, you still see the same way of management. So it's pretty easy. So you can just set and leave it as it, and then you can go for your event. So can you please next, please? Okay. For my session here, right, I would like to share my recent use case and deployment experience on why you should consider to modernize your Informix system with HCL Informix. Yes. But due to the NDA, right, I'm not allowed to share this user's details. However, I will share you high-level information about the project background, selection criteria, and overall project approach, including challenges encountered during the deployment. Thanks. Next, please. Oh, okay. Why we are there? I mean, because DBSoft is the competent HCL Informix partner to provide Informix technical support and Informix license know-how to advise to the client as well. Next, please. All right. Our client setup background. I trust that many of you are having the similar configuration or setup like this client. There is your application have many years of deployment on Informix system. They are legacy from a very old Informix system, it could be. So in this case, our client is started 20 over years ago with Informix version 9.40 running in 2 data center. They have more than 10 Informix 14.10 and other version as well running on the Red Hat server farm. And to meet the HA requirement, the Informix system also deployed with Informix Connection Manager and HDR setup for high available. And the database instances are sizing from, I mean, couple of few hundreds of gigabyte to terabyte of data. And most of the time, the system are actively with 10 of thousands of connection to this data server, either via JDBC or ODBC kind of connection. Next. So like many others organization, this client is also they're having their ICT strategic plan from time to time. And this round, they would like to take up a transformation, modernization project for their core business application. And the initiative is actually on upgrading and re-architecting their critical legacy system to achieve and enable digital transformation, and also hope to improve the productivity and find a possible way to reduce the operation cost. So it's quite a big ambitious that is actually to want to achieve from this exercise, because the project is also aimed to align their IT infrastructure with the strategic business goal, like evolving for cloud deployment. I mean, they consider whether it's on-prem or maybe outsource it to a managed service cloud providers. So, and also at the same time, because of the multiple database server environment and database schema all around everywhere. So they're also looking into, if possible, that is also put into a single database footprint, and also a database possible, also a database standardization and adoption of new technology from the current market. Next. Frankly speaking, I mean, after years of the system is actually running in the environment, they know the task is not easy and straightforward, especially they want to know how far IBM Informix can offer and meet their long-term plan. I mean, part of the consideration also, they even look for, is there any others or available alternative database platform, and considering to migrate the data server into a non-Informix platform. So these two options is actually in their business discussion in terms of the ICT planning. Next, please. Well, from their finding to the IBM Informix, so they get, of course, they get to know that. I believe that everyone get to know that is actually there are many additions. Okay, I mean they are good or bad. Okay, they are good or bad. Many additions, but each with the different feature set or missing certain features. So that means if you think that now you only suitable for this edition, but along the way, if you require to get advanced features, you may need to change the edition. You may need to acquire a new edition. Then only you entitled for the the edition or the features that you are able to run for your application. So it's quite uneasy to make a decision on whether you should get it now or you should get the edition later on. So of course, also the other thing also, the IBM licensing model is quite complicated. I mean, for many of you may have that same experience. Of course, the biggest drawback and a source of confusion is the gap between the features, pricing term across the different edition. So that is actually very uneasy to make decision what edition actually you should deploy for your this new project, for your new system. Next, please. Not only the edition that you have challenges, and you also have to consider what kind of scheme, what kind of the licensing scheme that actually you should opt for. I mean, you have processor value unit, PVU, you have AUSI, you have AU. I mean, you have EPC. You have various of this licensing scheme that you need to have a better understanding. I mean, to know what actually you're looking for. Next. So basically, the client are not easy and get very confusing with complexity on the licensing calculation. We do have a joke among our this project team. We need to get a very strong legal team. I mean, employ a big legal team to study and understand each license terminology, like the PVU, AUSI, AU, VPC, and etc., before we very acquire or procure all this license, because you are not that easy. That is actually after the acquisition of the licensing, the asset, whether you're compliant or not, you may have the challenges on that as well. So basically, the client are tired with software compliance issue, and you also have to ensure that your usage and licensing are effectively provisioned and comply with the IBM terms services. So based on my knowledge, is that some of the organizations who don't manage this may become liable to fine from IBM as well. So thanks. Next. So knowing the facts, the client have 20 years worth of data, because for 20 years, actually very huge, the data actually accumulated into the data server. So software deployment and then the integration and the customer facing processing running on the Informix database. So to move out this Informix data to any other platform, you require significant cost. Okay, the effort to make things happen. So switching that, the client after the study also, they switching that off to migrate everything to a new platform, bring an extremely very high risk of downtime, complication, and potential loss of revenue. So after the evaluation of moving to non-Informix platform, right, is very, very high risk, I mean, considered by the client. Next, please. Well, sometimes thing was just the timing was just right for HCL Informix version 15 launch and GA on the 14 November 2024. So that is actually the very right timing where client is actually found an additional option for their modernization project. So next, please. Okay. The very key point here is this. The HCL Informix has the product parity with IBM Informix. So that means it's the same binary code, it's the same features. So it's a very easy path to move on with HCL Informix. Of course, the very initial is that they have doubt with this. They have many questions about this. So next, please. I would like to share. And the other thing also, they also get to know is actually the data size of the version 15, right, is huge. So the team also, they understand that the HCL Informix team, right, have made a very big effort and enhancement to unlock the Informix features, unlock the Informix limit. So they really consider that this is the very potential data platform that they should consider to do evaluation with it. Next, please. So because of that, right, they are looking for this a proof of concept, and also they're asking us to provide the technology update, and also they're asking our effort, our help in terms of complement proof of concept POC for the version 15 in their environment. They have here Informix proof of concept with the client. Next, please. Okay. As you know, I'm not going into detail of the activities involved in all this upgrade and migration. These are what are task list. I believe that JC and the rest, right, they will share you more detailed information, technical detailed information later. So what I'm going to let you know is here is actually in our POC, right, we have in place migration and helping the client to upgrade from the current existing Informix system, right, to the HCL Informix system 14.10. Okay, so customer also tested the same version of the ODBC and JDBC driver, and they experience the same performance result as per existing setup. And the compatibility, the workability is all 100% achieved. So the testing is achieved with this in-place upgrade. Next, please. Further to that also, right, the migration, the continue with the migration POC and upgrade to the Informix 15.0.1 and 15.0.2. Okay, here there is a two version here, the two patch version here. The reason is actually is that we have done the POC with both database operating in compatible mode, level 0, and switch to a native mode on to the level 1 as well. And tested with the old and latest version of ODBC and JDBC driver, right? We did encounter certain challenges on the 15.0.1, and we managed to get the support from the lab and to fix some of the problem, and we deployed successfully on the 15.0.2 without any problem. So currently, the lab is not running on the compatible mode. Currently, the system is actually running on the native mode, okay, for some of the application. Next, please. Okay. So conclusion, the customer after the POC, right, it demonstrated that they could efficiently modernize their aging IBM Informix application, right, using HCL Informix, and they get to know that also avoiding millions of dollars in service and training costs, because the training cost is actually because can be avoided because it's that it still use back the same command line, the same system for their supporting their system. So the learning curve is actually very, very fast and very, very low. So that would have required this a quick time to market for their new application. Next, please. So over here, with the conclusion here, the justification to modernize with the HCL Informix 15 is very good to go, because Informix remains a viable option for the existing specialized or embedded application where it's set and forget reliability, high uptime, and strong performance in time series and data management. So what attracts the client, whether it's IBM Informix or HCL Informix, they both share the same parity of code. I mean, the capacity of the version 15 also give a very, very strong commitment to the users that the Informix is there, and is even grow bigger in terms of the more features from the Informix. So another thing is actually they also really appreciated that the deployment of the Informix is cloud native deployment as no additional cost. And the migration, there are options like support in-place migration or upgrade from previous version also, because they can very easily move from their older version onto the latest version. And one very key thing is actually when the selection of the HCL Informix, right? Because there is only one edition, there is only one version, which is equivalent to the IBM Informix Advanced Enterprise Edition. So you have all the features, you have all the functionality, so you don't have to like asking a question is that, what if, let's say in the future, if I need that features on the other edition, can I can I sort of trade up, or can I sort of replace my existing license to use that or not? So here you don't need to, because it's that you have all the features. You entitled for all the features. You can use all the features. And one more is also a very, very crucial and decision-making kind of main decision-making kind of factors. That is actually is very easy in terms of the licensing scheme. It's all based on the core license. So you just have to declare how many core license you are required for HCL Informix. And lastly, okay, because for us, after so many years of experience with Informix, we will be more comfortable, we will be more convinced that if we can work directly with the lab engineering, so to get the level 1 and level 3 support directly from the lab. So this is also one of the very cool key point. So we want to deal with the code developer directly. So we don't want to have any layer in between, frankly speaking. Next, please.
Hey Liew, sorry, there is a
Yes.
question from Chung. He raised
There
his
is a
hand.
question from?
Yeah, so he raised his hand. So maybe Chung, do you want to ask your question? All right. Not sure. Yeah, please go on, Liew. Sorry about that.
Oh, okay. So this come to my last slide, just to post you the latest update. So currently, some of the application are deploying on the HCL Informix 14.10 and 15.0.2. So we have two version of Informix system which is running. Of course, ongoing, everything will be deployed on the cloud with active mode. We have on-prem and also the MSP cloud data center as well. So we are having a very positive feedback. Okay, so we are work in progress to deploy the many others. This system will be running on the HCL Informix. So thank you. Is there any question?
Nothing yet, Liew. All good.
Nothing. All right, thanks.
Cool. All right. Let me share my screen. I'm assuming you can see my screen. Cool. Yeah. Cool. Yeah. Thanks all for joining again. Myself, Nag, I'm the channel sales engineer supporting APAC. So thanks, Liew and JC, for giving a compelling presentation. Now I'm going to talk about upgrading to HCL Informix 15 and 14 as well. So why should I upgrade, right? So when we look at the value of upgrading, it boils down to three pillars. One is efficiency, security, and future-proofing. First things first, let's talk about technical efficiency. Newer versions allow us to manage significantly larger data sets without the manual headache of fragmenting tables. And we also gain faster archiving and better tools for evaluating index utility, which directly translates to lower administrative overhead. And second is risk mitigation, which in turn is security, right? Now, we are in the world of AI, and security is absolutely paramount. So staying on older versions means operating outside of end of support dates. And this isn't just about the software itself, right? It's about the underlying hardware and OS compatibility. Now, upgrading secures the environment with modern encryption and ensures we have immediate resolution for known defects and security vulnerabilities, so we can stay away from all the hacks and attacks. Finally, talking about modernization, which is the third pillar. Specifically, if you're looking towards the cloud, the latest version make the transition seamless. Whether it's on-prem, VMs, or Docker containers with Kubernetes, the platform is now designed for that hybrid cloud flexibility. Now, just summarizing about these three pillars around efficiency, security, and future-proofing. By upgrading, we aren't just patching a system. We are gaining a more performant, scalable, and secure foundation that is much easier to maintain. So now we move on to impacts of migrations on business, right? So when we discuss migration, we must look beyond the technical cutover and consider the broader operational impact on the business. Talking about that, there are 5 key areas we need to account for. One is business process disruption, mitigation planning, staffing, training, and cost. Talking about business process disruption, we must evaluate how the transition might temporarily stall or alter day-to-day workflows. And with mitigation planning, success depends on our ability to identify risks early and build robust contingency plans. We don't want to have reactive fix. It should be proactive healing, right? And in terms of staffing, migration places a heavy demand on our people. So we need to ensure we have the right internal and external talent to support both the new environment and the transition itself. And that's when Liew's role is paramount here. And with training, a new system is only as good as the people operating it. So we must factor in the time required for the team to become proficient. So there is an effective training that's required. And finally, cost, right? So we look at the total investment and not just the software itself. So we also should factor in the combined logistical and human capital costs. And by addressing these 5 areas or 5 pillars proactively, we ensure the migration is a strategic upgrade rather than a disruptive event. So moving to the next slide, now I'm going to talk about the migration planning, right? So if you see here, this slide pretty much outlines a structured approach to migration planning to ensure minimal risk and downtime. So we start with creating a clear migration plan, evaluating infrastructure needs such as new platforms, storage, compute, and capacity requirements. Even in place migrations, additional space and performance planning are critical. So next, we assess operating system hardware. So whether upgrading the OS, applying regular patches, or moving from a 32-bit to 64-bit environments. So that's what we assess. And talking about networking issues, networking is often overlooked by crucial, right? So for instance, IP changes, client connectivity, and ensuring sufficient bandwidth for data movement must be validated early in the game. So as I mentioned in the previous slide, it's more about proactive healing instead of reactive break fix. Then we address application and client migrations, ensuring components like eSQL-C, ODBC, .NET, Java, or even 4GL applications remain compatible and functional. And before we go live, we thoroughly test everything, both backend systems and client-facing operations. And finally, we define a strong backout plan, and every migration must have a recovery strategy, including the full backups and clear rollback steps at each stage. And with that being said, a successful migration isn't just about moving systems, right? It's not moving from lower environment to higher environment or lower version to higher version. It's about reducing risk through structured planning, validation, and fallback readiness. So in the next few slides, I'm going to talk about the pre-migration steps, right? So if you see here, so if you're currently having version 11.7 or later, you can migrate directly to 14.10 or 15. However, if you are in these lower versions, you should first migrate to version 11.50, 11.70, or 12.10, and then consider moving to the higher version, which is 14.1 and 15. So the next pre-migration step is about OS, right? So if you see here, this slide talks about the supported operating systems for Informix either 14 or 15 as part of our pre-migration planning. So on the left that you see here, we see platforms supported by both IPM and HCL Informix. And this includes Linux distributions such as RHEL, SUSE, and Ubuntu LTS versions, eggs on PPC, Windows Server editions from 2009 all the way up to 2022 and later, Linux, and upcoming ARM support as well. Now, on the right, Linux on YES390 is supported under IBM environments. Now, the key takeaway here is that the OS validation is a critical pre-migration step. Before upgrading or migrating, we must confirm architecture compatibility, whether it's PPC or YES390 and so on, along with OS versions, patch levels, and whether it's a 32-bit versus 64-bit considerations. The next pre-migration step is pre-task, right? So in this slide, I'm going to talk about the critical pre-migration tasks to ensure data consistency and system stability before shutting down the source server, which in our case, it's the lower version, right? So first, we initiate a fast recovery unit using on init -yes to confirm there are no open or incomplete transactions. And this ensures the engine is in a clean state before proceeding. Following that, we verify the database integrity using onCheck utility that you see here. And there are some series of onCheck utilities. So we validate reserved pages, extents, system catalog tables, data pages, and indexes. And this step is essential to detect any corruption before migration, because migration does not fix underlying data issues, Then finally, we properly close all the transactions and shut down the source database server in a controlled manner. We move to, quiescent mode using on mode command that you see here. Wait for users to disconnect, advance logical logs, force checkpoint, take a level 0 backup, and confirm backup completion before executing a clean shutdown with on mode YUK. Now, these are all the commands as we are in the Informix world. We all know about this, right? But it's just a refresher. But the key message here is about discipline. So we should ensure transactional consistency, structural integrity, and a recoverable backup before migration begins. Remember, these are all the pre-migration steps. Then I'm going to talk about verification. And this, again, another critical step, because, why it is critical? Because we need to validate the environment against the target HCL Informix version requirements. Now, start by reviewing the machine nodes and release nodes to understand any deprecated features. That's absolutely critical. We also should understand behavioral changes or OS level prerequisites. Now, on the Unix or Linux systems, confirm that required kernel parameters and system limits are properly configured. Verify that sufficient DB space, physical log, and logical log capacity are available to handle conversion activities during the upgrade. On top of that, also ensure the source server is completely offline before initiating migration to prevent any data inconsistencies. Specifically for Unicode environments, confirm that this environment variable, which is GLU environment variable, matches on both source and target systems. Additionally, if the IFX extend role parameter is enabled, set it to 0 prior to the upgrade to avoid authorization conflicts related to data blade modules or external UDRs. Now, thorough verification at this stage minimizes upgrade failures and post-migration issues. Then I'm going to talk about capture information, right? So at this stage of migration, the focus shifts to capturing the complete configuration state of the existing Informix environment. But before making any changes, ensure that all configuration files are backed up, which I'm pretty sure you will already be doing. And this provides a rollback reference and allows comparison post-upgrade. Again, now for Unix or Linux environments, capture the primary configuration files, including onconfig, and we have all the other onconfig files like std and onconfig variants. Also, backup SM versions, ADT config file, and ADT masks, as these impact storage manager and auditing configurations. Now, networking and connectivity definitions such as SQL hosts and IXBAR server num must be preserved as they define listener configuration and backup metadata. In addition to that, the terminal capability files like that you see here, TCTER, the term cap and term cap should also be retained where applicable. Now, the same holds good for Windows environment as well. And the equivalent files under HCL Informix etc directory and related directories must be secured, including, again, onconfig.standard, all variants, SM versions, ADT config, ADT masks, and IXBAR server num. Again, the key objective here is to ensure the entire runtime configuration connectivity setup and auditing configuration and backed up metadata are all preserved prior to the migration, which we again discussed in the previous slide. So this enables accurate reconstruction, validation, and troubleshooting if required after the upgrade. And moving on to the next pre-migration step, which is having a list of all or checklist of diagnostic information. So this allows performance comparison after the upgrade and simplifies troubleshooting if issues arise. Because for now, we took the backup on everything, and this is going to make sure we can also do the performance upgrade as well, a performance comparison. Now, start by collecting SQL query plans for regularly used and complex queries, such as using the set explain on that you see here. And this provides a reference point to validate optimizer behavior post-migration. Then run db schema command for critical tables to capture distribution statistics. Also execute oncheck -pr command to dump root reserved pages. And these outputs preserve structural and metadata details. And make a full copy of onconfig file. And this is essential for rollback scenarios and for validating parameter consistency. And since oncheck PR does not capture all the configuration parameters, that's why you'll have to take a full copy of onconfig file. In addition to that, capture all environmental variables using the env command to ensure runtime settings are all properly documented. And during peak workload periods, gather runtime diagnostics save an online.log snippet, including checkpoint durations, and then run onstat-af command that you see here for a system-wide snapshot. And for deeper analysis, execute repeated onstat commands with -r, which is a recursive option, over several minutes. And you have all these commands here. Finally, at the OS level, collect vmstat, iostat, and SAR for CPU and IO metrics, and capture timex output for a frequently executed queries. And again, the goal here is to establish a comprehensive performance and configuration baseline before migration, enabling accurate validation after the upgrade. That way, you will be rest assured that the performance has improved after you migrated to the new version. Now, that concludes all the pre-migration steps. And now I'm going to talk about the post-migration steps. Now, assuming that we have completed the migration, after completing the migration, the next step is to prepare the new server version for production use. And this involves a structured set of validation and configuration tasks. To start with, if you are using OnBar or other storage managers, copy the SM versions file from the old HCL Informix directory, etc directory, to the new one. And this ensures backup compatibility. Next, consider running update statistics on key tables and UDRs, especially if you observe performance differences after the upgrade. Now, this helps the optimizer make accurate execution decisions in the newer version. On top of that, data integrity validation is also critical. And use onCheck command to confirm that no corruption occurred during migration. And we have several onCheck commands that you see here. Now, from IDS 11 onward, a new system admin database is automatically created in root DBAs. So what it does is it collects system metadata by default and stores DB cron scheduled tasks. And if needed, you can move it to another DB space using the reset system admin task to prevent root DBAs from filling up and causing more space. Now, as a best practice, enable new features or modify on-config parameters gradually. While many new features are enabled by default, review the updated onconfig.std file to understand the new parameters before making any changes. Finally, once validation is complete and configuration is confirmed, take a full backup of the upgraded HCL Informix instance. Now, this establishes a clean recovery baseline for the newer version. With this, I'll pass this on to the panelist. Please reach out if you have any questions.
No, they have some questions in the chat here. They can't speak up. So feel free to address. It looks like Casey has one. You're on mute.
Sorry, I'll address that. Thanks, Nick.
Okay, JC, are you ready?
Yes, I'm ready to go if you're ready for me.
All right.
Okay, great. Let me get my video going here. And I'm going to share some windows. Okay, hopefully you can all see this font well enough. Try to zoom in a little bit if it's hard to read. Hopefully it's good. This is an online log, a message log, and this is a window I'm going to be doing some demonstrations in. And these are my slides. So I came to Informix as a support engineer, and like a lot of other people who were coming into Informix in the early 90s, we were single and had no lives aside from work. And we would literally spend our weekends and free time writing support tools that would help us during the week to solve down systems problems and other problems. That's what we did for fun. And eventually those tools made their way into the product. And we've had a lot of great support engineers over the years. We still have great support engineers, but they wouldn't be able to do what they do without tools some really interesting tools that are built in to the product and some other things I'm going to show you today. This is just for fun. This will not be on the quiz. You aren't expected to learn how to use these tools. This is not a tutorial. A lot of these tools are not accessible to you. They're really just support only tools. But I thought it would be fun for you to kind of stand behind me and look at my screen while I do some things that support engineers do behind the scenes when they have serious problems to solve and to diagnose. Just a taste. So let's start with onCheck minus capital S. This is an example of a tool that customers do not have available to them. But I'm going to run it. Oh, also I'm using version 15.0.2 here. This is the bleeding edge. This is not a released version of the server, as you know, probably. So God knows what's in here aside from the things I want to show you. We'll see. It should all go fine, but if something goes haywire, just forgive me because this is a work in progress version. So I'll show you onCheck minus S in a minute, but first I'm going to do this. I'm going to show you that I have some entries in my storage pool. This guy here is a big file system that has at least 7 terabytes in it. So I'll create a DB space with a really large chunk. That's not something you can do in version 14. And I'm going to give it a 256K page size. No problem. So I'll show that to you. Here's that chunk that the storage provisioning feature created. These are in units of 256K pages. That's quite a big chunk. Let's create a database. And I'll use some of the new syntax with unbuffered log, just to make it a little more fun. Now I'll create a table. You would think that would be the end of the schema, wouldn't you? Our maximum row size in version 15.0.1 and below is 32K, but I'm going to go on. And on. And why don't we do one more column? Oops. I'm going to create it in this new DB space. I didn't have to do that. I could have created it in root DBS, but I'm going to create it there anyway. So in version 15.0.2, coming down the pipe, you're going to be able to create row sizes up to 32 meg. This is 128K, I think, per row. Let's see. Maximum row size. That's 100, looks like 128K to me. Insert into JC tab values. Column 1 data. Column, oops. Column 2 data. Column 3 data. Column 4 data. Select star from JC tab. Why don't we create an index on column 1 here? That's a 32K char column, but I can create an index on it in version 15 because it's in a 256K DB space. All good. We'll check the index. All good. Let's look at the data page that has that one row on it. So here's this is a partition, printing of the table space info. This is the metadata for the data partition, and this is the metadata for the index partition. You can see the index here, and the data fragment is above. So this is the partition number for the data fragment. I'm going to run oncheck pp partition number. I happen to know that that page 1 is where that row is. Let's take a look at the row. You can see column 1 data shown there, then followed by many, many blanks. It's in slot 1. And it's at this page address. Let's do this. I'm going to overwrite that column 1 data with some garbage using this special version of oncheck, or it's built into oncheck, but you're not allowed to use this feature. It's called oncheck-S. There's the main menu for it. It can do many, many things. Again, this is a combination of all the tools that were built in the 90s and later. You can dump pages, you can patch pages, you can look at logical log records, you can do all kinds of stuff. I'm only going to show you a couple of little things here. So I'm going to dump chunk 2, offset. Let me go back up here and get the offset. And I'm going to print 1 page, and I'm going to suppress duplicate lines. So there's the page, the data page. And here's the column data. And note that so this is the byte offset into the page where you can find the information. This is a hexadecimal of the data in hex format. And this is, for convenience sake, an ASCII translation of that. So really, this is what I'm going to hit here. And it's at byte offset 20. So I'm going to switch from dumping to patching. Same chunk, same offset. Byte offset hex 20. And I'm going to say JC was here. Now when I dump that same page, you can see my garbage is in there. So I have an index on this row. That index is, in the index, we don't have this garbage data. We have the original data. So when I boot up here and check the index, it's not going to be happy, is it? It's going to say that, I found something in the index that is not in the data partition and vice versa. So there's the results of my oncheck. It's saying, this data is in the index, but then I found this data in the row. What gives? And it's saying, please drop and recreate the index. So we could do that. That would be one solution. But imagine that I don't have one row in this table. I've got billions of rows in the table, and I don't really want to do that. I could fix the patch that I made to the data row to put back the original data, but let's do something more fun. Let's patch the index itself to make it synchronized with the data. So again, I go back to my PT output. This is my metadata for my index. The index partition has that partition number. I'm going to print that partition number. I happen to know that the root node is on page 1. And you can see the original data is in the key value that's in the index there. This is at offset that. So I'm going to shut down again. And instead of dumping the data page, I'm going to dump the index node. And you can see the original data there. That's at byte offset hex 30. Why don't I just patch that guy? Let's see. P for patch. Byte offset hex 30. And I'm going to patch it with a string. You can use this tool to patch 1 byte. You can patch it in hex, patch it in decimal, or with a string. I'm going to use this. So I can see that in my index node, I now have this garbage data. This was one way to solve the problem. Let's see what onCheck CI thinks. Perfectly happy. You access JC, select star from JC tab. And you can see that that patched data is now in there. So that's the dumping and patching tool that support uses all the times with down system support. And they can do very surgical things with it, but there are also some built-in patches that the tool can do for specific scenarios, like the following. Here's my big chunk. I'm going to shut down. I'm going to move that chunk to another file name. And now if I start up the server, oops, hold on. Thought I had shut down. I didn't. So now if I start up the server, it's going to notice that chunk is missing and it's going to bring the DB space down. You'll see an assertion failure in the log here. It's not happy because it couldn't find the file. But the server won't fall over. It's just going to bring that DB space down. So if we run onstat-d, we'll see we've got a D flag for down here next to this space. And we've got this chunk down. That was the only chunk in the space, so it brought the space down. And it's now waiting to write a checkpoint. It's not going to write a checkpoint until I give it permission to do so, because once we write this checkpoint, then those flags are on disk and permanently there. It's offering me the chance to try to fix the problem and shut down the server as it is and all that. If I shut down the server now and move that file back into place and restarted, that would fix the problem. But I'm going to make things worse here just for fun. I'm going to override that guy and write the checkpoint. So everything is the problem is permanently there. Excuse me. And now I'll shut down. Now if I move my file back, that's not going to help, is it? I have fixed the problem, but the server doesn't really know that. As far as the server is concerned, this space is down and needs to be restored from an archive. I didn't take an archive, so I'm in a little bit of trouble here. You can see that the space is still showing it's down. Chunk is still showing it's down. DB access. Select star from JC tab. It's not going to happen. Could not open database table, primary or mirror chunk is bad, etc. Kind of as expected. So now I can use this the special version of onCheck to fix this problem. I'll run onCheck -S, and I happen to know that it's the space options that will help me here. If I do this, it'll show me a more drilled down version of the menu. So I can run S-A to mark all chunks online and enable all spaces. And then I give it a -Y to confirm that, yes, I want to do that. -A, -Y, change is done. This is an example of a specialized patch. There were multiple patches that happened in the background there. You have to patch the DB space structure in the reserved pages. You have to patch the chunk structure. You might even have to patch a couple of other things in the reserved pages to make this work. But now our space is back online. Our chunk is back online. DB access, JC, select star from JC tab. All good. So that was onCheck -S. Let's look at, let's see. When I started up and we got the assertion failure, an assertion failure file was produced, and a raw stack file was produced, and a shared memory dump was produced. I can actually view this shared memory dump without disturbing my current server. My current server has these shared memory segments in memory. The server's running, all is fine. But I can actually read this shared memory dump into memory and look at it with onstat without disturbing my running instance. I do cat, Informix dir, temp, that guy, and I pipe it to onstat-g in. That takes it from standard in, loads it into shared memory, and produces what are called facade segments. These are the segments I just produced. They can be found by searching IPCS for facade. I have to run onstats against this shared memory dump that I just read into memory. I have to say onstat-s0 for this guy, and then whatever normal onstat command I want to run. So -d to see DB spaces and chunks. You can see that it's marked here in the banner as being not real. These are facade segments I'm looking at. I can see what threads we're doing at the time of this shared memory dump. You can see that the fast recovery thread was the one running. That's the guy that reported the problem. And these were the segments that were up at the time, etc. So any onstat command I want to run, I can run against this shared memory dump. It's a static dump. It's a static set of segments. But there's a fair amount I can learn about the problem from this shared memory dump and the assertion failure file, which took a bunch of onstats and gathered evidence, etc. I can now delete these segments by doing DSG. So now I just got my instance running, and those are the only segments that I have up. So let's look at shared memory pools. Here, I'm going to show you some slides here. Oh, yeah, I'll show you that in a sec. So I've shown you onstat-s and the facade segments. And now I'll show you something really cool. Here are my shared memory segments. In the virtual shared memory segments are memory pools. You can see a list of all your pools with onstat-g mem. Those are all my memory pools. Pools consist of memory blocks or fragments. This memory pool here has 7 allocated fragments and 1 free fragment. This guy has 29 allocated fragments, 4 free fragments, etc. Let's look at one of these pools that's a large global pool. Onstat-G minim RSAM. This is one of the bigger pools. You can see it has 6,700 allocated fragments and 221 free fragments. So there's a lot going on there. And the RSAM pool is also a global pool that we could look at, but let's look at the RSAM pool. I can print all those allocated fragments from the RSAM pool by doing AFR, RSAM, typing that to less. These are all the memory allocations that have been made from that pool. This is the address of the block header for this block. This is the size of the block. This is the type of memory in the block. And this is where that memory was allocated in our source code, believe it or not. I'm not using a debuggable server here. Even in the field, you will see information like this about where exactly this allocation happened, which is very helpful for support. Let's find one of these blocks that's sort of interesting. How about this guy? This part in memory means that it's used for table spaces. So let's take a look at this guy. Onstat-G dump OX that. And this guy. We'll see that many bytes. That'll show me everything in that block. Now, this all looks like gibberish to you, but to a support engineer, this is mostly understandable, believe it or not. The block header is here, the first 3 lines, and the rest is the body of the block, and this is being used for a partition structure. I can tell that from the name of the mutex here. That's a mutex for a partition structure. And I can actually use what's called the structure dumper that's built into Onstat to dump out the block header there. You have to know the type that you're looking for, which is, in this case, is block header T. Again, this is not a debuggable server, but I'm able to almost use a debugger on it because I have this Onstat command that was written by Dan Wood in the late 90s. He was an advanced support engineer. It's showing me the various elements of the block header structure and their values. And this all looks pretty sane. I can see that the size matches the size I was expecting, etc. So I feel like I've, hit the right spot here. It's telling me the size of the block header structure is 48 bytes or 30 decimal. And I can use that same structure dumper to dump anything in shared memory. Let me run onstat-g again. This is the address of the DB space structure that's for that big DBS. Onstat-g dump. That guy, DB space T, is the name of the structure. You can see that the DS name is big DBS and the owner is Informix. So it looks like I've, my command has worked here to print the information I'm looking for. I didn't miss it. The DB space number matches what I was expecting. You can see the DB space flags match what's in here. So clearly I've got the right address and the right structure and all is well there. And again, support engineers use this all the time to examine shared memory at a very low level and make sure that everything looks sane. Let's say that I used the wrong address here. I ran it with a slightly different address. The structure dumper doesn't know anything about what's at that memory. It's dutifully printing out whatever I type I've given it there. But as a support engineer, I can see that this chunk number doesn't look right. The name looks garbled. This is the kind of thing that if you've hit the right address and you find this kind of thing rather than what you're expecting, which is this sort of information, you'll have to try to track down what happened to corrupt that memory. And here's the chunk structure. Onstat-g dump OX this. It happens to know the chunk structure is called IFX, chunk T. Chunk number looks sane. Size, this is in base page units. So that's why that doesn't match this number. If you divide that number by 128, you'll get this number. Page size is 256K. That looks correct. DB space number and the name looks good. So I've hit the right spot and I've got the information I want. Almost any type in our source code is understood by this onstat command. It's just infinitely useful, especially in the field where you don't have debuggable executables. So let me show you another slide here. Here's some lines from onstat-g seg showing a shared memory segment, a virtual segment. And now we're drilling down into that segment and we're looking at the RSAM pool, which consists of, fragments. So we're going to drill down further and see inside the RSAM pool that we have allocated blocks and free blocks. Here's an example of one of those blocks. There's where it was allocated. And here's what a block looks like, an allocated block looks like. When a thread requests memory, it will get back this address of the body of the block. That's the address it wants to be able to write to. Preceding that address is going to be the block header that I showed you. That's going to contain information like the size of the block, the type of the memory, etc. And these block headers are all linked together in a linked list in the pool. And so that's how we get from one to the other. If the block header gets corrupted, then all heck breaks loose, obviously. Here's a good block header. No, I take it back. Yeah, that's right. There's a good block header. It starts with a check word. So if someone in the previous block has written beyond the memory they allocated, for instance, sometimes you might allocate memory for an array of 100 integers, and you might write past that array accidentally because of a defect, right? We'll know right away because the check word and the adjacent block will be munged and won't calculate right when we check it. But we may not recognize that problem for a little while. We're not constantly walking the linked list in memory pools. We're only modifying and looking at specific parts of the memory pool at any given time. So if a particular block header gets corrupted, it may be seconds or minutes before the server really notices it. By that time, the evidence of the problem has probably long gone away, and it's hard to work your way. As a support engineer, it's hard to figure out what happened upstream to cause that corruption because of the delay between when the corruption actually happened and when the server discovers it and assert fails. So in 15.0.2, we have written a new feature called memory guarding. I'll show you a little bit about that now. Again, this isn't something that you as a user will work with. This is something that's for support, really. This is a segment being represented as a bitmap. Each of these little ones or zeros here represents 8 bytes in the virtual segment. And that those 8 bytes are either guarded or they're read-write. In the case of ones, that means that the memory is read-write. So we can write to that memory and nobody will complain. But if those 8 bytes are represented in this guard table as a 0, meaning they're guarded, if we try to write to that memory, we'll get an assertion failure. So when we allocate a block of memory, we want to guard the block header, for example. Let's take a look at that block header again. So that block header is at this address. And it's the block itself is that many bytes. So let's look at what that guy looks like in the guard table. Onstat dash guard. And then we'll give it this address and this size. This is what that memory looks like in the guard table. We've got 6 bits representing 8 bytes that are guarded. That's what the zeros mean. And that's the block header. The block header is 48 bytes big. 6 times 8 is 48. That's the block header. The body of the block is read-write. That's what all those ones mean. And then we put a little padding after the body and guarded it, just in case we try to overwrite that body of that block. We'll know right away. If we try to write to anything that's represented in this table with a 0, as I said, we'll yell about it. So this isn't something that you would have on enabled during production. Typically, it's going to sap performance a little bit, but if we get a reproduction for some kind of memory corruption problem and we turn this on and run the reproduction, the idea is that we'll find what the problem is very close to the top of the stream. Now, when you free a memory block in a pool, then we guard the whole thing, because you never want to be writing to a free block. So if we look at a free block in the RSAM pool, these are free blocks in the RSAM pool, and there's an address of a free block. And it's 64 bytes big. Notice that everything here is zeros. That whole free block is guarded. If we free some memory and then somebody tries to write to it again, we'll complain. That's not an atypical defect that all kinds of software has. If you free some memory and then you forget you've freed it and you try to write to it again, that's obviously bad. So a lot of times when you free a block, it will be reallocated right away. And in this with this guarding mechanism, as I said, an allocated block, the body of it is considered read-write. So if thread A frees a block of memory and then tries to write to it again, but someone else has allocated the block again, so now the block is considered allocated and read-write, we're not going to notice thread A writing to it again incorrectly. So what we do is we quarantine free blocks. This is a new feature in 15.0.2. These are all blocks in the RSAM pool that have been quarantined, meaning the thread has freed them, but they aren't really free yet for reuse. They're in quarantine. If I look for this guy in the allocated free fragment list, you'll see that the type of memory is quarantined. And if we look at that memory in the guard table, you'll see it's all guarded. So while it's in quarantine, it's not being reused. legitimately by any other thread. And if somebody tries to write to it, we'll scream about it. So those are new features that are coming in 15.0.2. They'll probably also be in the latest version of 14.10 as well, because most of our production systems are still on 14.10 out there. And these features are important enough that we really want to get them in the field. So FC13 is the latest version 14 out there. I think that FC14 will have this memory guarding feature and the quarantine feature in it. This slide kind of tries to depict guarded memory. And here's a shared memory segment. And this memory is read-write, this is guarded, then we've got read-write memory, etc. I think that's all I've got for you. I hope that was fun and interesting. That's just the tiniest taste of the tools that are available to support engineers to not only troubleshoot problems, but fix problems in the field. Things can be very sophisticated behind the scenes, and hopefully you would never know. Hopefully you would just be receiving word that something had been fixed and you don't know why that is, but you're glad about it. This is the kind of thing that goes on behind the curtain while you're patiently waiting for someone to deal with your case. So I guess I'm turning things back to you, Nick.
Awesome. Thank you, JC. So I'm looking here at some of the questions, and it looks like Nog has responded to them here in the chat. So if you guys have any questions, do not hesitate to reach out to us. And we're happy to have a conversation with you. But with that, I will wish you all a good rest of your day and a good evening to those of us on the other side of the planet. And hopefully we'll see you again soon.